Okay. Good afternoon, everyone. My name's Matt Hamilton. I'm a developer advocate with Protocol Labs. You probably know us from things like IPFS and hopefully Filecoin, which is what we're going to be talking about a bit here. But also what we're going to be talking about, or what I'm going to be talking about specifically in this talk, is about InterPlanetary Consensus. InterPlanetary Consensus is a project that we've been working on for a while with regards to scaling Filecoin and potentially other networks as well. So it fits in the sort of the layer 2, layer 3, layer 4 type space. I'm going to talk a little bit about the background about it, and also a little bit about what it can do, how you can get involved in it, and possibly some ideas as well for your hackathons, and talk a bit about the bounties, and maybe some questions depending on time. So like I said, Protocol Labs, you probably know us for things like IPFS. IPFS is 10 years old this year. We've been around for quite a while doing Protocol Labs stuff. IPFS is a decentralized storage network. You probably have used it, especially if you've done anything with NFTs. NFTs use IPFS a lot. And one of the key things with IPFS is it uses content-based addressing. You may have seen these addresses that start QM or BAY and a series of what looks like potentially random digits. Those addresses are actually derived from a hash of the data. So the idea is that if you fetch some data, you can actually verify that the data you get back is actually the data you requested. And also it decouples the location of the data from the actual data itself. So if you think about URLs, when you go along, you go to www.whatever.com/some folder name /report.pdf. That is telling you the location of the data, but obviously that could move. It might be in multiple places. And the whole idea behind the Interplanetary File System, IPFS, was that data could be stored in multiple places because you might actually want to fetch it from somewhere that is nearby. That especially becomes important when we start thinking about what does the internet look like when you start scaling beyond our planet. Now that might seem a bit of a lofty goal, but actually it informs a lot of the design thinking behind IPFS. And you'll see that reoccurring when I start talking about IPC, the Interplanetary Consensus. So we had IPFS. One of the issues, IPFS was great, but one of the issues was there was no inbuilt mechanism to actually incentivize anybody to store data. So typically, if you've used IPFS, you may have used a pinning service, someone like Pinata or Infura, in which you pay them to ensure that your data stays on the network. Now, your data may be replicated by many hosts around the network, but at the same time, they could all choose to effectively garbage collect and no longer store that data. It kind of acts a bit like a caching system. But you need at least one node that actually has that data pinned, and that means they're always going to serve it up. And that becomes a bit centralized with the way that works. Now, IPFS has been around. IPFS has no sort of blockchain concept at all, and has nothing to do with blockchain or cryptocurrency. The next iteration was Filecoin. So Filecoin is taking some of the concepts of IPFS and uses a lot of the same underlying technology, but to build a storage network in which you have a crypto-economic model behind it. So there's a Filecoin token, there's a Filecoin blockchain, and although the data is not stored on Filecoin, on the blockchain, the data is stored off-chain, the blockchain itself stores the proof that the data has been stored and the economic side of things. So who's paid what, how much, for how long, and all that kind of thing. And then on top of Filecoin, we have the FVM, the Filecoin Virtual Machine, which we launched a year ago yesterday. Yesterday was the first birthday of FVM. As far as I'm aware, we're the first and only layer 1 blockchain to retroactively add an EVM layer and a VM layer on top. So that was about a year ago. But the Filecoin network is huge. You're talking between 10 or I think we say 16 exabytes of data storage capacity worldwide. Put that in context, that's about 1% of the entire data center storage capacity on the planet. So that's it's pretty massive. We're also known for libp2p. libp2p is a protocol that underpins a lot of other blockchains. So I think Polkadot, Solana, I think Ethereum 2 all use it. It's actually written there, Ethereum 2, Polkadot, InChain, Golem. They all use libp2p as a mechanism for actually communicating between nodes. So kind of taking all these technologies together, we then, I guess sort of mentioned this, IPFS, a sort of migration, IPFS, libp2p with all of those networks is currently securing about $300 billion worth of value on those networks. So it's quite a significant thing. And then, like I say, Filecoin there on the end. But ultimately, like I said, if you start looking sort of beyond our planet, and this may seem, like I say, a bit of a lofty goal, but it informs a lot of the design thinking around IPFS and now IPC, you can't get away from the fact that the laws of physics mean it takes a certain amount of time to transmit a signal a certain distance, right? The speed of light. So getting data from here to the moon is going to take a few seconds each way. Going somewhere like Mars, you're talking, tens of minutes potentially each way, right? So how do we build a blockchain that could actually scale to those potential sizes there? So IPC, Interplanetary Consensus, is our way of trying to solve that. And the idea is to try and scale it to a level where we start to approach the speeds of Web 2 and possibly exceed Web 2. So Web 2 at the moment still has the speed advantage over a lot of stuff within Web 3, mainly because we're dealing with consensus mechanisms in Web 3, right? We have blockchains, we have consensus. We need to get a number of people to agree, to validate, to ensure the integrity of the system. But that has performance implications. The idea behind IPC is we can actually break a network up and have multiple subnetworks, each of which has their own consensus mechanism. So again, if we go back to the idea of being on another planet, the consensus mechanism of the blockchain on Mars doesn't have to be in like direct consensus with the blockchain on Earth. They could be separate subnets and then linked through a common parent. So as I say, sort of problems with blockchains, scaling to meet demand, that's the sort of problems we've got at the moment, scaling to Web 2 sizes. Bad composability. So if you use one blockchain, you're kind of, you've got to swallow it all in one go, right? You've got to use kind of how that blockchain is designed and how it is designed to do things. With Interplanetary Consensus, you have more flexibility. If you want to change out the consensus mechanism, change out the virtual machine, you can do so. It allows you to build kind of things as you want to build them. So we had, this has come out of a R&D lab we had at Protocol Labs. So we had a consensus lab within Protocol Labs. And then, like I said, last year, FEM R&D started in 2021. Last year, we actually launched it. We started productionizing IPC, Interplanetary Consensus. So to give you kind of a bit more of a feel for it, like I said, we talk about scalability in terms of subnets, in terms of creating this hierarchy of networks. Each child can have its own children, so you can create a layer 2, layer 3, layer 4 of them, and so you can create vertical scalability, but also horizontal scalability as well. You can have subnets that are region constrained, so you might have a subnet within the EU, within North America, within Asia, for example. Again, to try and work on the basis of it still takes time to transmit signals, right? And if you start to scale these things up and need to be going faster, then you may need, for example, a subnet that specifically is running within one specific geographic region just to deal with the laws of physics and the time which it takes you to transmit signals. An interesting point that somebody brought up earlier on at the Filecoin booth, can't remember who it was, they may be in the room, was about that certain geographic regions may have certain legal implications around blockchains and what you can and cannot do. So you might not be able to have proof of work in one region or proof of stake in one region, for example. So you may have to actually alter your consensus mechanism dependent upon the region. And IPC allows you to do that because you can create subnets within different regions that all then connect up to, like I said, a common parent there. So within IPC, you can use IPC to scale a particular application out to multiple regions or create application-specific subnets, appchains, right? So you might have a particular application that you want to run. So some of the, as an example, at ETH Oxford the other day, last week, Some people created a sort of decentralized Discord type service in which a group of friends can have a group chat going on between them, and they can each run a node, and they create effectively a private blockchain that just exists for the communication between themselves, right? That could then, like I said, that could be anchored to a parent level blockchain, and through that could then access other blockchains and other group chats that are running this system. There is a network called Fluence that is launching, I believe, later this month. Fluence is a decentralized compute network, and they have used IPC as the basis for what they are building because they want to actually do certain specific things that they can't do on the main network. So IPC allows you to create custom actors, custom like built-in smart contracts that could be written in Rust and directly compiled to WASM, and also custom custom syscalls that can access outside of the EVM or the VM sort of sandbox you're within. So if you want to access external hardware or external libraries, external services, maybe you want to actually access something like some AI libraries or something like that, then you can do that with that. And you might have specific ones that are tailored for certain things, like hard privacy. You might want to have a subnet that's dedicated to fully homomorphic encryption, something that is currently at the moment a very intensive process you wouldn't necessarily want on a general purpose subnet, but you might want to have your own separate subnet that can do FHE, for example. So like I said, it's effectively infinitely scalable because you can actually build subnets off of subnets off of subnets. And also the idea is sort of going forward, at the moment we've restricted it, just to be aware, we've restricted it just to layer 2 off of a layer 1 for now, just while we're working on things. In theory, you can go layer 3. We've just disabled that at the moment, just while we're just ensuring that everything works there. A lot of this is still very much in development, although, like I said, we have got a production project that is going to be using this and going live, I think, later this month, Fluence. So, yeah. And like I say, it's customizable. So you create your own subnet. You can choose things like your own gas schedules, your own native tokens, membership rules. Might be a public network, might be a private network. Your own block time. And you can also, like I said, customize things like create your own, you could put your own runtime on there, right? So say you wanted to port over the Solana runtime and run it on there, or the Move runtime, you could do that as well, right? Or create custom syscalls that can access outside information. So just kind of giving you a sort of diagrammatic view of what this could look like. So you could have layer 1 mainnet and IPC at the moment. We anchor to Filecoin. But in theory, you could anchor to any EVM network at the moment because it is based upon Solidity contracts deployed to the parent. Or potentially even Bitcoin. We're actually investigating at the moment IPC being a layer 2 for Bitcoin networks. And then, like I said, you could have subnets that might be specific to a particular application or genre of application. You could create a gaming subnet or a subnet for a particular game, or subnets for particular regions as well. And one of the things we're working on as well is the idea of kind of ephemeral subnets as well. So imagine you created a game, you have a subnet that is only necessary for the duration of that game, just between the players of that game, just to ensure that, you know, nobody is cheating and the rules are all being followed. But then once the game is finished, you don't need that entire subnet. So that subnet could then just be torn down. So it could just be run for just the duration of that game, or duration of a compute job, or some sort of task, and then effectively roll up the end result and the output, and maybe any proofs that you might need to, you know, validate the process up to the higher level chain. I think I've probably covered most of this already, talking about what a subnet can host. So like I say, different things, different applications, different geographic regions. Yeah, so deploying a subnet is kind of like sort of a start of a journey. and then it could expand onto a whole topology of its own. So it depends whether you're running it. You could have a whole ecosystem running it as well. You could determine the incentives for what people might get for running a node. Ephemeral lifetimes. This is what I was talking about just earlier. You might have things like, games, compute sessions that just need to run for a short period of time, and then the subnet can be, destroyed at the end of that. So this is something that we are working on. This is not, the ephemeral subnet is not available sort of particularly at the moment. I mean, you can simulate it. You can fire up your own subnet, do what you want, and then shut it down. Effectively, that's what you'll be doing for this hackathon. You'll be starting up your own subnet locally on your laptop, and at the end of the hackathon, it will disappear. So in terms of bounties, we have 2 bounties from Filecoin. So the first one is sort of a general bounty around Filecoin. So that's not particularly what I've been talking about in this talk, but is about just general tooling and products that involve onboarding data onto the Filecoin network, or working with the Filecoin economy as well. So anything to do with lending and borrowing on the Filecoin network, utilizing the storage primitives of the network as collateral, for example. So you can actually create storage pools and lend and borrow collateralized by, lending pools collateralized by storage, for example. And then what is most relevant to this talk is we got a bounty for most meaningful use of InterPlanetary Consensus for scalability. So if you were to spin up a consensus subnet here and deploy stuff to it, then that'd be eligible for that bounty. One thing to be very clear is, like I said, we're very known for IPFS. Just using IPFS on its own is not qualifying for the bounties, right? We've had a number of bounties in the past at various hackathons where people have just used IPFS, and that is not sufficient to qualify for the bounty. So you need to use Filecoin either via one of the third-party aggregators, or generally you would use one of the third-party aggregators, projects like Lighthouse.storage, Web3 storage, NFT storage. There's a new project that's just come out called Textile Basin. That's a data lake by the people behind Tableland, which is a SQL database on top of Filecoin. So yeah, those are all potential options there as well. And a couple of QR codes that take you to link to some cheat sheets for the hackathon that give you some more information and some stuff about our tech as well. We've got a Filecoin booth. If you've not seen it, if you walk out of here, we're just sort of straight ahead and slightly to the left at the back there. And by all means, come up and chat to us. I'm also hanging out on the Discord channel, the ETHGlobal Discord channel under the Filecoin ETHGlobal Discord server on the Filecoin channel. So come along there if you have any questions, or come and find us in person. And I think I've got about 5-10 minutes left. If people have any questions about IPC or about Filecoin in general, then feel free to ask them here. Or like I say, you can come and grab me afterwards. Yeah?
Yes, I have a question regarding, do you have some examples of projects that already use subnets, some dApps or some projects already on mainnet?
Okay, so the question is, do we have some examples of projects that are already building on IPC that are on mainnet? Just to be clear, IPC is not deployed to mainnet yet. It's deployed to our testnet called Calibration. So it's not yet on. I mean, in theory, you could deploy it to mainnet, because at the end of the day, its anchor is basically a series of Solidity smart contracts. So you could deploy it to Filecoin mainnet. Obviously, you'd be paying gas for real world gas for doing that rather than testnet gas. In terms of examples, we've got a couple of examples in the GitHub repo, and I will put some links directly in the Filecoin channel on the Discord. So we've got one example of using general message passing, GMP. We've got a general message passing protocol to communicate between a subnet and a parent, and there's an ERC20 token example, what's called a linked ERC20 token, and that's showing how you could have, say, an ERC20 token on the parent network, then be transferred to a account on the subnet by having it basically the parent effectively escrow that token, and then the child effectively mint a replica of that token on the subnet, and then when the token's sent back, it's burnt and then it's released at the top end. So effectively an internal bridge using GMP. So we've got that. I think we have another more complex example that is using what Fluence is using, that is in conjunction with Axelar and doing a bridge from another network right the way in, which is quite an example. But come and have a chat. Like I said, we had some people building at ETH Oxford last week, and I think they're about here, and so I can sort of chat about what they were doing, the sort of Discord type chat thing as well. But ultimately, you can use IPC. It gives you just to be clear here, it gives you an Ethereum endpoint, RPC endpoint that you can deploy to. So you can deploy using any your usual Solidity, Remix, Hard Hat type tools directly to a subnet. So we have a in our docs. So on that one, the QR code will take you to a link. One of them is our docs, but it's docs.ipc.space. And in there we have a quick start deploying a subnet. And that will take you through the steps of deploying a subnet. It will compile a bunch of Rust stuff locally on your machine. Depending upon your machine, that may take a while, so be aware. That can take, say, depending on your machine, might be a quarter of an hour, might be an hour to compile stuff on there. So that allows you to basically compile it, initialize your config, ensure that it's pointing at the right place on the parent network, and that the what's called the gateway and the registry addresses are correct, and then setting up some wallets on there, and then creating the subnet that registers your subnet with the parent network, joins your nodes to the subnet, and then you can deploy a child validator here. Now, this example, you'll see the commands repeated 4 times. That's for setting up 4 nodes on the network. Actually, if you're going through this, you just need to deploy 1. I mean, it'll be a consensus of 1, which is a bit artificial, but for the purposes of the hackathon, save yourself a bit of time, and you can run just a single node. And ultimately, when it's successful, you'll get this message here, and you'll see the ETH API show up there, right? So you can then configure that in MetaMask or Hard Hat or Forge or whatever you're using, and access it. We'll get a chain ID there as well, and away you go. Great. Yes.
All of the repos, if I want to go and deploy the contract, where can I find the contracts?
So the question is, where can you find the contracts? So the contracts that are actually deployed as IPC is the IPC itself is actually using. So those will be within the what's called Consensus Shipyard. There's an organization called Consensus Shipyard. This may be linked in the quick start docs there. If not, there we go. It's now in the Filecoin Discord channel. So in there, the contracts should be within there. Yeah, so it should be within there. Now, I think some of the contracts are, there we go, IPC Solidity actors. So there's information there. And if you need any information specifically about what they do, I can give you some more information about that. But in short, there's 2 contracts. One is called the gateway actor, and one is the subnet actor. And for each parent, there's 1 gateway actor that acts as basically a registry for all the subnets. And for each subnet, there's 1 subnet actor. And that gateway actor is also used as a sort of a post box for the GMP, the General Message Passing Protocol, to communicate between subnets. Okay. Cool. Any other questions? Brilliant. Well, thank you very much. And like I said, you can come find me at the booth, sort of towards the back wall, slightly to the left, or you'll find me on the ETHGlobal channel on Discord. Great. Thanks.